For lesson 9, we're going to work on converting between standard form and vertex form for our quadratics based on a process that we actually already know that we used in previous lessons. So consider the following quadratic functions. Describe what we know about the graph of each function just by looking at the equation. So this one here, 2x squared minus 8x minus 24, is in standard form. The only thing that you can tell in standard form is if it's concave up or down. Now this one is going to be concave up because it's a positive number in front of the x squared. Now you can actually tell concave up or down based on all of them. See how they all have that positive 2 out in front. But from our regular one here, we can tell that. And then we can also tell that our y-intercept is negative 24 because that is always our last number that doesn't have any variables next to it. Okay, so in the middle here, f of x equals 2 parentheses x minus 6, x plus 2. So now we're not going to talk about the concave up again. We know that piece. But this is going to tell us our zeros. Remember, zeros have the opposite signs of what's in here. So if it's x minus 6, it's x equals positive 6. And if it's x plus 2, it's x equals negative 2, right? So opposite signs between our factors and our zeros. And then the last one, again, concave up from the 2 out in front, but this last one is in vertex form, so it tells us what our vertex is. So remember, it's the opposite sign of what's inside, so positive 2, and the same sign as what's on the outside, so negative 32. So you can see 3 different forms of the same quadratic tell us 3 different things based on looking at it. So we want to rewrite f of x equals 2x squared minus 8x minus 24 in vertex form by completing the square. So you may have forgotten how to complete the square. Now, we could take a GCF out of this whole thing, but what I would like to do is just take the GCF out of the first 2, because that's normally how we do our completing the square. So when we do that here, we're 2 and we're x squared minus 4x. Then we're going to have plus a line inside, and then we're going to be minus 24 minus a line outside. Okay, and then when we complete the square, we're set equal to, well, if we're going to solve, we'll set equal to 0. If not, we'll just be set equal to f of x. So now remember how we complete the square. We take our middle number, so negative 4 divided by 2 is negative 2, and we square it. So negative 2 squared is 4. So that's the number that goes on that first line, so plus 4. Now normally it would be minus 4 on the last line, but we have to remember with this 2 out in front, if we distributed the 2, what is 2 times 4? 8. So then minus 8 is what has to go on the last line. So now the whole point of completing the square is to get this to factor into the same parenthesis twice. So how do we know what it factors into? Remember, whatever you get when you divide by 2, that is going to be what goes in your parentheses. So when we divided by 2, we got negative 2. So it's going to be x minus 2 squared. That 2 is still out in front. Then negative 24 minus 8 is negative 32. And there is our quadratic function in vertex form. Okay, so we're not going to do any solving once we get to vertex form. We're just going to put it into vertex form, and that is going to be our answer. Okay, so sketch a graph of f of x by using all the information we have about this function. So if we look, this is the same exact one from the opening exercise. So what did we know? We knew it was concave up, and we knew it had a y-intercept at negative 24. So we'll put the y-intercept down there at negative 24. We know it had zeros at 6 and negative 2. So negative 2 and at 6. Now remember, this is all estimation. And then we found out the vertex is 2, negative 32, which notice we could have gotten from here, opposite sign of what's inside, same as the outside. So 2, negative 32 was our vertex. So if we were to sketch our quadratic based on these features, we would get a graph that looks something like that. Okay, so we have our zeros, we have our y-intercept, and we have our vertex. based on the three different forms of that equation. So number 2, it wants us to write the following quadratic functions in vertex form, identify the vertex, and state if it's a minimum or a maximum. So the first one here, x squared plus 6x minus 2, we don't have to GCF anything like we did in the first one because there's nothing in front of the x squared. So all we're going to do is we're going to move right into moving or putting in our lines, okay? And we're just going to keep that y equals out in front the whole time. So we'll take the middle number. 6 divided by 2 is 3. 3 squared is 9. So 9, and because there's nothing to multiply out in front, we just have plus 9 on the first line, minus 9 on the second line. So y equals, what does this parenthesis turn into? Well, we know it's going to be x. When we divide it by 2, we get a positive 3, so x plus 3 squared. And then negative 2 minus 9 is negative 11. So our vertex is going to be negative 3, because the opposite sign of what's inside, negative 11, same sign as what is outside. And then because it was positive out in front, it's going to be concave up. Okay, so now let's try the next one here. Now, we have a number out in front, so we're going to GCF the 5 just from the first 2. So x squared plus, and when we divide 20 by 5, we get 4x, and then plus a line, and then plus 23, and minus a line, okay? So now we'll take our middle number here, divide by 2. So 4 divided by 2 is 2, and 2 squared is 4. So on that first line goes 4. And then we're not going to put a minus 4 back here because we have a number out in front, so we have to multiply. What is 5 times 4? 20. So on that back line goes a minus 20. F of x equals, we keep that 5 out in front. This factors into x plus 2 squared, and then positive 23 minus 20 is a positive 3. So what is our vertex here? We should have negative 2, positive 3, right? Opposite, same. And then this 5 is still positive, so it's going to be concave up. So as we look here, now we're going to start to put some negatives out in front, okay? Here's where we got to be a little bit careful in some of our steps. So whenever there's a negative out in front, even if there's no number, we still want to take out the GCF. In this case, since it's just a negative, we're just going to take out a negative 1 from the first 2 only. So that becomes positive x squared, positive 12x, and then plus a line, minus 33, minus a line. All right, and again, we're going to have to be careful here. So this part's still the same. Middle number divided by 2, so 12 divided by 2 is 6. 6 squared is 36. So on the first line goes to 36. Here's the first part where we really have to be careful. We have a number out in front. It's a negative 1. So negative 1 times 36 is negative 36. So on this back line, we should be negative 33 minus negative 36. All right, we have to be very, very careful with this. H of x equals, now you could keep it as negative 1, or you could just put a negative sign out in front of the parentheses. They mean the same exact thing. So we're going to have negative, and then in parentheses, x plus 6 squared. And then here we're just going to be careful. If I were you, I'd probably use my calculator. Negative 33 minus negative 36. You should recognize that this turns into plus plus, and you end up with a positive 3. So what's our vertex here? Our vertex is negative 6, positive 3. And because we have a negative out in front of our parentheses, we are going to be concave down. If you think you have a handle on this, what I'd like you to do is pause the video and try the next one for g of x on your own. If not, just wait a second and we'll work on it together. So now for g of x, we have a negative and a number. So we're going to take out that negative 2 from the first 2 pieces. So we got to be careful now. Negative 2 comes out of here and gives us a positive x squared. When we take a negative 2 out of this, it becomes a negative 2x. So plus a line, plus 7, minus a line. Okay, so we got to be careful. When we take out that negative GCF, both of those signs are going to flip. So middle number divided by 2. Negative 2 divided by 2 is negative 1. Negative 1 squared is 1. So on that first line goes a positive 1. We have to check here. So negative 2 times 1 is a negative 2. So we end up with minus negative 2 on that last line. G of x equals negative 2. This becomes x minus 1 squared. And then 7 minus negative 2, so plus plus. So 7 plus 2 gives us a 9. So what's our vertex? Our vertex is the opposite of what's inside. So positive 1, same as on the outside, positive 9. And then because there is a negative number out in front of the parentheses, we are going to be concave down. Okay. So now we've done some of these in our regular standard forms here where we're just kind of looking at them as a regular problem. Now what we want to do is look at how we can apply them to maybe a word problem a little bit. So we want to jump ahead here to number 5. A high school baseball player throws a ball straight up in the air from his math class. The math class was able to determine that the relationship between the height of the ball and the time since it was thrown could be modeled by the function h of t equals negative 16t squared plus 96t plus 6, where t represents the time in seconds since the ball was thrown, and h represents the height in feet. So time is really replacing our x's, and h is really representing our y's. At what height does the ball get thrown? Okay, so when you talk about what height does the ball get thrown, that is your starting height. And if you remember back from earlier in the year, anytime we talk about starting something, that is always our y-intercept. Okay, so if we look at our equation here, negative 16t squared plus 96t plus 6, our y-intercept is always that constant that's by itself at the end. So what was the starting height? The starting height was 6 feet, all right, because we're plus 6 at the end of our equation, all right? So that y-intercept, always synonymous with starting, and is always the constant part of our function. Algebraically determine the maximum height, and at what time did this height occur? Whenever they're talking about maximum height, they're talking about our vertex. So what we need to do now is we need to do our completing the square that we just practiced to this problem in order to find out what our vertex is. So h of t equals negative 16t squared plus 96t plus 6. So again, we're going to take out that negative 16 from the first two. So what does that leave us with? A positive t squared. Careful. So 96 divided by 16 is 6. But because we took out a negative 16, we have to switch the sign. And then we'll be plus a line, and then plus 6 minus a line. All right. So we take our middle number, divide it by 2. So negative 6 divided by 2 is negative 3. Negative 3 squared is 9. All right, so that first line gets a 9. But now negative 16 times 9 is what's going to go on this back line. So I'm going to do that in my calculator. So negative 16 times 9 gives me negative 144. So on this back line, I get minus negative 144. So now if we go to put this into vertex form, we get negative 16, or h of t equals negative 16. What does this factor into? This becomes t minus 3 squared. And then if we have a positive 6 minus a negative, so minus minus becomes plus plus. So really we have 6 plus 144 gives us 150. So now our vertex is going to be positive 3, positive 150, right? Opposite of what's in the parentheses, same as on the outside. So we found our vertex. Now let's talk about what each of those pieces means. So the max height was at 3 seconds. So that first number always represents your time. So it took 3 seconds to reach its maximum height. And in this case, the y value tells you what your max height was. So the max height was 150 feet. Okay, so it took 3 seconds to reach your maximum height, and your maximum height was 150 feet above the ground. All right, we can tell all of that by our vertex form. When does the ball hit the ground? So I'm going to actually go here to a double page display so I can see. Now, what we want to do is we need to set this equal to 0. Okay, so our standard form one doesn't really help us. Now, you could go to your calculator, but if we wanted to do it algebraically, the best way to do it would be to take our vertex form equation and set it equal to 0. So we're going to be, actually I'm not going to start with h of t. I'm going to start with negative 16 t minus 3 squared plus 150 equals 0. So in order to solve this, I'll start by subtracting my 150 on both sides. Negative 16 t minus 3 squared equals negative 150. Divide everything by negative 16. I get t minus 3 squared equals, now let's go to our calculator here, negative 150 divided by negative 16 gives us 9.375. Sure, we'll go with that. You could also keep that in a fraction if you would like. Square root, square root. Okay, I'm going to come down here on the side. So I get t minus 3 equals, now there's a really good chance that that number does not give us a perfect square of any kind. So what I'm going to do is, I'm just going to leave this as plus or minus square root 9.375. I'll add the 3 to both sides, and we get t equals 3 plus or minus that square root. All right. So now if we want to figure out when the ball hits the ground, we're going to solve each of these. So we get 3 plus that square root. Okay, and we're going to need our calculator. So 3 plus square root 9.375. And let's go to the nearest tenth of a second. So 6.06, I'm just going to round to 6.1 seconds. Okay, now we're going to do the same thing, but we're going to minus that square root. And when we do that, and here's where we're going to have to be careful and use our brains a little bit, we get negative 0.1. So let me ask you something. Can you have negative 0.1 seconds? No. So that's going to reject, and we're going to have 6.1 seconds as our answer. All right, obviously the ball can't hit the ground after negative 0.1 seconds, so then we have to go with our 6.1 for our answer. All right, so now if we want to state and finish up this problem with an appropriate domain and range, well, our domain is our x's, which is being replaced by our time. So when does this start? Time always starts at 0 seconds. And when does this end? This always ends when the ball hits the ground. So therefore, it's going to end at 6.1. Okay, so our domain always goes from the starting time, which is 0, to the time it hits the ground, in this case 6.1. Now our range always goes from the ground, which is 0 feet, all the way up to the maximum height, which is 150 feet. Okay, so our, again, domain, 0 seconds to hits the ground at 6.1 seconds. Range, it's 0 feet above the ground, on the ground, and to its maximum height, which in this case is 150. So see, most of these domain and ranges always start at 0, and then you have to figure out when it hits the ground for the domain and when it reaches its maximum height for the range.